Hello and welcome to all students. This is FY BCom semester second class, mathematical and statistical techniques. Second, unit number 9, binomial and Poisson distribution. So in the previous lecture we studied what is mean by binomial distribution, and also we have solved some problems on binomial distribution. In the previous lecture we solved problems about mean and variance of a binomial distribution. Now in this lecture we study about a Poisson distribution. So we define what is Poisson distribution and when it occurs. So it arises while counting the number of occurrences of a rare event in a long series of trial. So this Poisson distribution occurs in the experiment where the occurrence of a particular event is very rare. Okay, so for example, some examples are given here also. So this means that the distribution is expected when the chances of any individual event being success is very small. So in the experiment, the occurrence of success, if we perform our experiments many times, then and here the occurrence of success is very small. In this case the Poisson distribution occurs. Poisson distribution arises. Okay, so some examples are given here. The number of accidents on a road in a particular time period. Suppose in a particular time period, if we count the number of accidents on a road and the possibility of happening this event of accident, that is a very rare case. Okay, so and second example is number of white blood cells in a cubic centimeter of blood. So we know that in our blood cell there are red cells are in maximum in number, but white blood cells, they are uh, very rare. Okay, so what is so Poisson distribution we can define in other word, it is nothing but a binomial distribution. So Poisson distribution is nothing but a binomial distribution with parameters n and p, but the condition is that so n is very large, means number of trials are very large, and the probability of success is very small. Okay, so a binomial distribution with parameters n and p becomes a Poisson distribution when n is very large and p is very small. So probability of success is very small, and in case of number of trials are very large. Okay, so we perform experiments in very large number, then in this case also the probability of success is very small. In this case we can say that it is a binomial distribution, we can say it is a Poisson distribution. Okay, here now let us go to the next. So there is a one number. So while defining the Poisson distribution, we use one number. That number is called as that number is denoted by this notation, and this number is nothing but it is a Greek letter. It is called as lambda. And the value of this number is nothing but n into p, product of n and p. Okay, n means number of trials and p is nothing but probability of success. Then the then the probability of getting success x times. So we write here the probability of getting success x times is given by so if we perform our experiment in n number of times, and out of these n number of times my probability of success x times, that probability is given here. So probability of getting success x times, it is equal to given to be a lambda raised to x into e raised to the power minus lambda and whole divided by x factorial. Okay, so this is our Poisson distribution. Okay, so remember this. Here lambda is nothing but product of n and p. It is a parameter. Okay, what is e is nothing but one real number whose value is so while solving the problems, the value of e, they will give the value of e. Okay, so don't worry about this number. Okay, and what is x means number of times we get a success. And in the example, if the lambda is not given directly, then we can find this lambda by using this relation. Okay, so there are some conditions on Poisson distribution. Okay, so what are these conditions? We will write here now. So write here some conditions on Poisson distribution, that is important. Conditions on Poisson distribution. So first condition is here given: the variable must be discrete. The variable must be discrete. That is, that variable must take values like this 1 2 3 4 dot dot dot. Okay, second second is the number of trials n is very large. So number of trials, so n must be very large. And what is n means very large. So n means number of trials. So this number must be very large. And third is the probability of success is very small. So p means probability of success, and it must be very small. Okay, next fourth is np n into p must be finite. Finite means a fixed number. Okay, and the probability of success in each trial is constant, and the probability of success in each trial must be constant. Okay, so it is okay, probability of success p must be constant. So these are the conditions on So now we have defined what is mean by Poisson distribution, conditions on Poisson distribution also. And now let us study about the mean and variance of Poisson distribution. Mean and variance of Poisson distribution. Poisson, Poisson distribution. So first of all we write the mean of Poisson distribution, mean, and that mean is denoted by, I think, x bar. Okay, so let us see now. For a random variable x with Poisson distribution, with parameter lambda we have defined above, so that Poisson distribution is here. Okay, for a random variable x is equal to x. Okay, for random variable x is equal to x, with parameter lambda the Poisson distribution is this. It is defined here, and here x takes values 1 2 3 dot dot. Okay, the mean and variance of such a Poisson distribution is nothing but a lambda. Okay, so let us write here the mean means x bar of Poisson distribution, x bar mean is nothing but lambda, and variance we call it is sigma square, and that is variance is also equal to lambda, and the value of lambda we know that it is n into p, and here also n into p. So mean and variance of this is second thing is variance. Okay, okay, variance. So in Poisson distribution, mean in Poisson distribution, mean is same as variance, and the same value is lambda, and lambda has value n into p. So while solving the problems we will use this thing. Okay, so let us go to the problems now. Let us write question number 1. Okay, let us write question number 1. Let us we solve some problems based on mean and variance of Poisson distribution. For question number 1, for a Poisson distribution, for a Poisson distribution, for a Poisson, p must be capital here. See, p must be capital. For a Poisson distribution with lambda is equal to 0.7, find probability of x is equal to 2 and probability of x less than or equal to 2. Okay, comma, given that e raised to the power minus 0.7 is equal to 0.497. Okay, so problem is very simple. Okay, so first of all let us write the answer for this question. So we have given a Poisson distribution with lambda is equal to 0.7. Okay, and value of e raised to the power minus 0.7 is this much. Okay, so first of all we write what is that Poisson distribution p of x. Okay, so just write like this: p of x is equal to x in probability of success x times it is equal to, it is given by lambda raised to the power x into e raised to the power minus lambda and whole divided by x factorial. Okay, and here x may takes value 1 2 3 dot dot dot. Okay, so in first case we have to find the value of the probability of x when x is equal to 2. That is very simple. Now just go to the first case. Okay, let us go to the first case. So find out just probability of x is equal to 2. So this x I will put now 2 here, and it is equal to, values are given, value of lambda is 0.7, raised to the power x is 2 into e raised to the power minus lambda is again 0.7. The value of e raised to the power minus 0.7 is given to you, and x factorial means it must be 2 factorial, and we know that 2 factorial is 2. So by using calculator we can find the value of 0.7 square. Okay, so it must be 0.49, and the value of this number e raised to the power minus 0.7 is given to you, and that value is 0 point, again the 0.497. Okay, and whole divided by 2 factorial is 2, and if we do the product of these two things and divide this product by 2, then we get the answer 0.12165. Okay, so this is the value of getting success two times in this Poisson distribution. Okay, so this is the value of getting success two times in Poisson distribution. Now we go to the second case. First case is over. Now second case, in second case we find the probability of getting success in in at most two times. Okay, in at most two times. So meaning of this is nothing but at most two means probability of getting success one times, or probability of getting success two times included, or okay, probability of getting success at most two times means we have to find probability of getting success one times plus probability of getting success two times. Okay, at most two means two or less than two, two or less than two times. So we find the value of p of 1 and p of 2 separately. So p of 2, the value of p of 2 is known to us, we find value of p of 1. Okay, and it is very easy. Okay, so let us go find p of 1, or find here p of 1 separately. We call it is equation star. Okay, so p of 1 is equal to so now it is lambda raised to x. So x is 2 here, here x is 2 in first case. So we write here lambda raised to the power x into e raised to power minus lambda divided by 2 x factorial x factorial, x factorial, and now we put the values. So lambda is given to be 0.7 raised to the power x is 1 into e to the power minus 0.7 divided by x factorial, means here it is 1 factorial, and it is equal to, now it is 0.7 into the value of this factor is 0.497 divided by 1, and this the value of, so there must be one more term here. Okay, x may take value p of 0 also. Okay, so there must be one more term we have to add. So we have to add this term. What is that term? P of 0. So x may take value 0 also. Okay, success may get 0 times. Okay, so 1, 2 and 3 we are finding p of 1, and the value of p of 1, the value of p of 1 is we write here 0.3479. Similarly, we find the value of p of 0. Now find the value of p of 0, and it is equal to lambda raised to 0 into e raised to the power minus lambda uh, divided by 0 factorial, and it is nothing but e raised to the power minus lambda, but e raised to the power minus lambda is minus 0.7, and its value is given to be 0.497. So up to now we found these two values. Okay, now equation star becomes, so what is that equation star? That was left hand side was p of x less equal to, and it is equal to p of 0 plus p of 1 plus p of 2. Okay, and it is equal to, so p of 0 has value 0.497 plus, as we have calculated above, and p of 1 has value 0.43479, and plus p of 2 has value 0.121765, as we have calculated above. So if we add all these terms, then we get 0.96665. Okay, so probability of getting success at most 2 times is equal to, okay, is equal to 0.966665. Okay, so this is the way of finding the probabilities. Let us write one more question based on mean and variance of a, okay, so let us write question. So question is, if a random variable x follows Poisson distribution such that if random variable if a random variable x follows if a random variable x follows Poisson distribution with, p must be capital, POISSON, Poisson distribution with p of 1 is equal to p of 2. Okay, and we have to find mean and variance. Find its mean and variance. So let us write the answer for this question. Let us write the answer for this question. So what is given to you? So follows random variable x follows Poisson distribution, that is given to you. So x follows Poisson distribution. So we know that what is p of x, okay, and it is given to be 1 minute. That is not like this. Okay, p of x is equal to x. Okay, probability of getting success x times, it is equal to lambda raised to the power x into e raised to the power minus lambda and whole divided by x factorial. But what is given to you? Hmm? We have given that, given, we write here, given that p of 1 is equal to p of 2. So for we write p of 1 here. So what is p of 1? From this formula it must be lambda raised to 1 into e raised to the power minus lambda divided by 1 factorial. So x is equal to 1 here, okay, and it is equal to on the right hand side, and on the right hand side, what will be p of 2? It is lambda square into e raised to the power minus lambda divided by 2 factorial. Here x is 2, okay. So just we have to simplify this expression and find the value of lambda. Okay, find the value of lambda. So it is very easy. So we see here how much easy. Okay, so let us go. So see here, e raised to the power minus lambda, e raised to the power minus lambda get cancelled. What is left is lambda raised to 1 upon 1 factorial. 1 factorial is 1, therefore it is not necessary to write 1 here now. And on the left hand side it is left only lambda. On the right hand side here will be lambda square upon 2 factorial is 2. Okay, again we can take 2 on this side and lambda on this side. So 2 times lambda is equal to lambda square. So 2 is equal to, so transfer this lambda on this side. Here lambda is multiplied, here will, now lambda will divide on the right hand side, and 2 is equal to, so on the left hand side there will be lambda only, one lambda will get cancelled. Therefore mean and variance, we know that mean and variance of Poisson distribution is same, and the value is equal to lambda. The value of lambda is 2. Therefore mean and variance of a Poisson distribution is 2. Okay, so thus this is the end of this lecture, and we stop here. Okay, thank you very much.